Question 14. Okay, so this is our first proper looking framework. We've got one single force being applied from above, and you're being asked to work out what is the internal force in this member here, in member EC. What you can do is pause the video any time you like and try and work it out. I'll take you through some points and then suggest where you should pause. What you need to do in your calculations is you need to focus in on this joint here, this C joint. That's going to give me the internal force in EC, because I'm only going to be cutting through these two members. So I need to be focusing on C. No, I don't have length units in this diagram, but there is enough information to solve the problem. If you like, you could treat the lower lengths as if they're 1 meter. But they're not explicitly shown. So that's what I did. I assumed that each one of these widths was 1 meter, and I used that then to do the next thing, which is work out what RC is going to be here. Okay, so it's a bit confusing here. Let's get rid of the oh, someone's at the doorbell. Pause the video. Well, you never guess who was at the door. Should I show you? Nah. Guesses in comments below. If anyone gets it right, you get a prize. Okay. Right, back to my solution. Yeah, I was trying to get rid of my horrible squiggles. Let's get rid of these so you can see what's going on. Okay, there we go, that's better. So the next thing you want to do is work out what the reaction is, RC. So I would do this by solving the problem by taking moments about A. So this is a point which I strongly suggest, if you haven't found RC at this point, that you pause the video and do it now. Hopefully you paused the video and didn't cheat. It's a straightforward problem. We got the 12 force here, newtons I guess, or kilonewtons, and it's coming down. We're going to measure it from this point here, from this point here, so it's 1 meter away, so 12 times 1, and we're going to take this distance to be 4 meters away. So 12 divided by 4 gives me 3 kilonewtons. So we've got a reaction of 3 kilonewtons. So that's our starting point to find the forces that are behaving around joint C. So we could write that on our diagram. Now we want to focus in on joint C. So we know we've got this 3 kilonewton force reaction, and we're looking for the EC force, internal force. So what I'm going to do is method of joints. I'm going to write it directly on my diagram for convenience, and I'm going to resolve forces in the y direction, because then that will get rid of this BC force. So that would only pick out the EC force. So I strongly suggest that you pause the video at this point, resolve your forces in the y direction, and see if you can work out what EC is now. First thing I would say is that, well, if that's 60 degrees from the horizontal, it must be 30 degrees to the vertical. And so when I resolve my forces in the vertical direction, I've got EC times cos 30. What else is pointing in the vertical? It's the free is, so that's going to be plus 3. Rearrange this, and we're going to get minus 3 divided by cos 30. So, oh yeah, I'm ignoring what I'm doing here. So what I'm doing here is I'm going to use my calculator. Yeah, so we got the minus 3 cos 30. So I'm not being a hero and trying to work out, oh, I know what cos 30 is. I'm just going to put that straight in my calculator and press equals. So minus 3 divided by cos 30. And the calculator tells me that's minus root 3. Okay, so we want the engineering solution. So we press the SD button. So the SD button, that thing here. Oops, we don't get the answer. So I'm going to have to do that. It's all going horribly wrong. So 2 root 3 SD button. And then that gives me minus 3 point, I'll do it to 3 sig fig, 3.46 kilonewtons. Okay. So that's question 14. Just one more question to go and then we're finished.